In this video, we'll go through the process of naming an alkyne. So recall an alkyne is a hydrocarbon that contains a carbon-carbon triple bond. When naming alkynes, the rules are very similar to naming alkenes, but the difference is going to be how the name ends. And so, as with alkenes or even alkanes, the first step is to identify your parent chain. Recall the parent chain is the longest continuous chain of carbon atoms. Now, one thing that I do want to point out before we actually assign a name to the parent chain, I think that with the skeletal structure, most of us can easily see that these represent carbon atoms, because we know that in a skeletal structure, each point represents a carbon. However, in an alkyne, there's often some confusion because most people will just assume that these are two carbon atoms here. However, you must include the carbon where the triple bond is located. Recall when dealing with VSEPR or your electron geometry, in the case of the triple bond, those carbon atoms have a linear geometry. So they're trying to be as far apart from one another as possible, which would be 180 degrees. And so even though it doesn't look as if it has a point, because we don't actually see a point, there are two carbon atoms where the triple bond is located. So when naming alkynes, make sure you include those two carbon atoms. Now we can go and determine our parent chain. So remember the little trick, you can take your pencil, pen, finger, go across the carbon atoms. As long as you're on a continuous chain, you don't have to lift up. However, if you're no longer on a continuous chain, that means you have to jump up to include that carbon. And so if we look at this molecule, 1, 2, 3, 4, 5, 6, 7, 8, 9, in order to include that other carbon, I have to jump up and go over to that 10th carbon. So it would not be part of that continuous chain. I could have also checked to see if I could get more in a different direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this molecule, my longest continuous chain of carbon atoms contains a total of 9 carbon atoms. So again, I recommend boxing off until you get confident and comfortable with naming. Once we determine that we have 9 carbon atoms in a continuous chain, we know that our prefix is going to be non. But it's not going to be non-ane. It's going to be derived from that, but instead of that ane ending, this molecule would end in yne, which indicates a triple bond. From there, we have to identify substituents. So we have one branch sticking out of that boxed area, which indicates the presence of one substituent. That one substituent contains one carbon atom, so therefore we're looking at a methyl group. So we have our parent chain, we've identified substituents, now we need to indicate where everything is located. So remember, you can number your parent chain from left to right or from right to left. When numbering the parent chain, you're simply saying what carbon numbers do each represent. So we're just numbering it from 1 to however many carbon atoms. So I can go left to right, I can go right to left. So I apologize for that lighter color, it's not showing up very well. But what that lighter color shows us is that if we went from left to right, we would have a methyl on carbon 2, and our double bond would start on carbon 5. If we went from right to left, we would have a methyl on carbon 8, but our our triple bond would start on carbon 4. And so you want your triple bond to have the lowest number possible. Just as if we were naming an alkene, we want the double bond to have the lowest number possible. But in the case of the alkyne, we want that triple bond to have the lowest number possible. And so even though the methyl group would have a higher number, because numbering from right to left gives our triple bond a lower number, this is the direction that we must number. So what that tells us is that our triple bond will start on carbon 4, and our methyl group will be located on carbon 8 of the parent chain. From there, we've identified the parent chain, we've identified the substituent, we've indicated where everything is located. Now we can put it all together to name the compound. When naming the compounds, any substituents that are present are listed first. If multiple were present, we would have to use or indicate how many and what types and where they're located, but they will be listed in alphabetical order. In this case, we only have that one, which is the methyl, we still have to indicate where that methyl group is located. So we have 8-methyl. We have to separate numbers from letters using dashes. We also have to indicate where our triple bond is located on our parent chain to give us the name 8-methyl-4-nonane. This indicates that we have a continuous chain of 9 carbon atoms with a triple bond that starts on carbon 4 and a methyl group that is placed on carbon 8. So as before, after you've determined your name, you can go back and check to make sure that you have accounted for everything. We had a total of 10 carbon atoms in our molecule. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Your name should account for those 10 carbon atoms. Non represents 9. Meth represents 1. So we've accounted for those 10 carbon atoms. We also had a triple bond, so that should be accounted for in the name. That YNE ending lets us know that we have a triple bond. So this is a good indication that you do have a correct name for this compound.